So as I come over here, folks, okay, we look at our flux capacitor. We have dealt already the other day with going from moles to representative particles and vice versa. So we've done that leg of the flux capacitor. Now today, we're going to bring this in. So we're going to go from moles to mass, mass to moles. Now, could we, let's think about this. Could I go from mass to moles, moles to representative particles, and then whatever that is to atoms? Could I do that? Yeah, so we're looking at, here is one step, here's two steps, here's three steps. I could do all of that in 3 steps just by doing the processes that we're going through, the factor label method. So what we are adding today here is the mass, and like we said, we are going to need the molar mass to go from mass to moles. So it's just a different branch on our flux capacitor. Here's the very first practice problem we're going to work. I'll give you a second here to jot it down in your notes, and then we will work it. The problem states how many moles are in 5.42 grams of chromium-3 sulfate. Now, you're probably starting to see the picture here, folks. Okay? You're probably starting to see the picture of how much is exactly involved in this particular problem here. Number one, I have to take the name, chromium-3 sulfate, and I have to write the formula. Then I have to take the formula, and I have to get the molar mass. I have to do all that before I can do the conversion. So you're going to see that we're bringing back knowledge from the last few units on how to do this one problem. Okay? We could have to use bonding to determine whether it's an atom, a molecule, a formula unit. Okay? Definitely nomenclature. Okay? And here we have a molar conversion too. So I look at chromium-3 sulfate. I know chromium is a 3+, sulfate is a 2-. So I'm going to need 2 chromiums, and I'm going to need 3 sulfates in order to have my net be 0. Okay, my net charge be 0. Now, in order to save a little bit of time, I have already calculated the molar mass, and I calculated the molar mass to be 392.18 grams per mole. So 392.18 grams per mole. Now, as I'm looking at the problem, I am given 5.42 grams. So that's what I'm starting with. 5.42 grams of chromium-3 sulfate. I set up my conversion box. Now, as I'm looking at my flux capacitor, as I go back to my flux capacitor, let me get all this junk that I wrote on there. Not junk, that's good stuff, but let's get all that out of here. I have a mass given to me. And I am going to moles. So when I have a mass given to me and I am going to moles, my conversion box is going to look something like this. I want the mass to cancel. So I'm going to put the molar mass on the bottom, and I'm going to put 1 mole on top. Now on the other side, okay, if I'm going up from mole to mass, it's just going to be the inverse of that conversion box. I'm going to have the 1 mole on the bottom so it can cancel, and I'm going to have the molar mass on the top. So in this particular problem here, I've given a mass. I want to go to moles, so I'm going to use that guy right there. So on the top of my conversion box, I'm going to have 1 mole of chromium 3 sulfate. And on the bottom, I am going to put my molar mass, my 392.18 grams of chromium 3 sulfate. Now, as I step back, the whole idea of my factor label method is to be able to get something to factor out, okay? I see a gram of chromium 3 sulfate. I see a gram of chromium 3 sulfate on the bottom. So that is going to cancel. So this will leave me with a label of mole of chromium, mole of chromium 3 sulfate, and I have to do my math. Now remember, once again, I multiply by things on the top, I divide by things on the bottom. So I'm going to take 5.42 and I'm going to divide it by 392.18. When I get my answer, how many sig figs do I need? I need 3 because that was what was in my original number given. So I need 3 sig figs. So my answer is going to be 0.0138. Box it so Mr. Braun knows where to find my answer. So final answer, 0.0138 moles of chromium 3 sulfate. Questions about this so far? Sweet. Here is practice problem number 2. Go ahead and copy that down. The problem states, what is the mass of 3.48 moles of sulfur 4 oxide? So here we go. Mr. Braun threw this sulfur 4 oxide to see if you know how to use the stock system of naming molecules. All right, I'm dealing with sulfur and I'm dealing with oxygen. So I look, I have sulfur, I have oxygen. Now, in terms of oxidation numbers, okay, I know that unless oxygen is a peroxide, it takes the charge of what? -2. Okay, so if this is going to be -2, -2, and I write a 3, what is that? This is going to be -2. Sulfur is +4. So how am I going to get those equal? I have to have SO2. Okay, so this is SO2. So sulfur 4 oxide is really sulfur dioxide. Now, just once again, in order to save some time, I already calculated the molar mass, and the molar mass is 64.0638 grams per mole. So I start out with what has been given to me. So I'm going to start out with 3.48 mole of sulfur 4 oxide. I do my conversion box, and as I'm mentally seeing my flux capacitor, I'm at moles and I am going up to mass. Okay, I'm at moles and I'm going up to mass. So I want my moles to cancel. So I know that 1 mole of sulfur 4 oxide has a molar mass of 64.0638 grams of sulfur 4 oxide. I look, I have moles on top, moles on the bottom, so I do indeed get a cancel. So I'm going to be left with the label of grams SO2. So when I do my math, I'm going to take 3.48. I'm going to multiply it by 64.0638. And when I do so, with my answer with 1, 2, 3 sig figs is going to be 223 grams of sulfur 4 oxide. So what does this actually tell me? If I were needing to get 3.48 moles, I would have to measure out 223 grams of sulfur 4 oxide. Go ahead and copy down my third example here. Copy it down. All right. So the problem states, what is the mass of 9.4 times 10 to the 24th molecules of diphosphorus pentabromide? Now, as I'm looking at this, okay, I see molecules. So I'm given molecules of diphosphorus pentabromide, and I want to go to mass. So as I look here at my flux capacitor, I know that molecules is down here, correct? So I want to go from molecules to mass. Can I take a direct route from molecules to mass like that? I cannot, okay? I cannot take that direct route. So that is not what we are going to do. We have to go from molecules to moles, then from moles to mass. So this is going to be a two-step problem. A two-step problem. So, as I come back here and I look, I am dealing with diphosphorus pentabromide. And as with the other ones, I've already calculated my molar mass of this. It's 461.4676 grams per mole. I'm going to need that here in a little bit. Now, what do? How do I start this guy? Well, I go with what's given to me. 9.4 times 10 to the 24th molecules of P2BR5. Now, I've got a two-stepper. I know, so I'm going to make a little bit longer conversion box. I have molecules right now, and I need to go to moles. So this is an Avogadro one. So I know that 6.022 times 10 to the 23rd molecules of P2BR5, that is equal to 1 mole of P2BR5. So as I look at that, I get my molecules to cancel. Ladies and gentlemen, what have I just converted this into? To moles, okay? I've converted this into moles. So now, looking at that flux capacitor, okay? Looking back at that flux capacitor, I just did step 1. So I'm right here at moles. Now, step 2 is to go to mass. So I look and I say, all right, I have moles on top here, so I want moles to cancel. So I know that 1 mole of diphosphorus pentabromide has a mass of 461.4676 grams of P2Br5. I'm going to close my box here. So I step back. I have a mole on top, mole on bottom. I do indeed get a cancel. So now I have to do my math. And once again, this might be where it gets a little bit tricky math-wise, because how I'm going to do this, I'm going to multiply everything on the top first of all. So I'm going to take 9.4 times 10 to the 24th. Do I need to multiply it by 1? No. So I'm going to multiply that by 461.4676. I hit my enter button. I execute my answer. Then I'm going to divide by the bottom. So I'm going to divide then by 6.022 times 10 to the 23rd, Avogadro's number. When I divide that out, I get a number of, okay? And I'm just going to write out, my number, and my label is going to be grams of P2Br5. As I write out my number, I get 7203.24716. That's the entire number my calculator just spit out at me. Well, I go back and look at my original number given to me. How many sig figs are there? Right there. 2, correct? So I have to have this number in 2 sig figs. So I can do one of 2 different things. All right? I can make this number 7,200. That's 2 sig figs, right? Or I can make this number 7.2 times 10 to the 3. So either one of those are correct answers. So probably what I would do, since it isn't that big of a number, I would put 7200 grams of diphosphorus pentabromide. The way I would work that. But you could have scientific notation, like I said, either or. Any questions on this particular problem? All right. Here is the last one that we are going to work. What I want you to do, I want you to copy this down in your notes, and then I want you to work this problem. I will work this problem once everybody is completed with it. Okay? So go ahead and copy this in your notes and do the problem. I'm going to go ahead and start working this. The problem states how many hydrogen atoms are in 5.49 grams of benzoic acid. So I'm going to set a little bit of a roadmap here of what I'm doing. I'm starting right here with a mass. I have a mass of benzoic acid. So I'm going to, number 1, convert mass to moles. Number 2, I'm going to go from moles to molecules, because remember we label acids with molecules. So that's my second step. Then I'm going to have to get another step in there, a third step, because I'm going to atoms of hydrogen. So this is going to be a 3-step problem here, people. If you can do this, and you did this correct, you really get what you're doing with the flux capacitor. Okay? This 3-step problem here. So I'm going to go back here, and I have, first of all, benzoic acid. So I have to come up with the name of this. IC 1 or 3. So, Will, what is this? Acid rule number? Acid rule number 3. There's no hydro in front of that. So I'm looking for ATE, benzoate. Benzoate is C7H5O2, a minus 1. So that tells me, with that minus 1, that I'm going to need 1 hydrogen. So there is benzoic acid, C7H5O2. Now, when I went through and I calculated the molar mass of that, I came up with a value of 122.1232. So there's my molar mass. I've got the information now that I need to do my calculations. So I'm going to start out with what has been given to me, the 5.49 grams of benzoic acid. I'm going to do my long conversion box. I don't know if I'm going to be able to fit all this on here, but I'm going to try. So I have to first go to moles. So I know that 122.1232 grams of benzoic acid is equal to 1 mole of benzoic acid. Now, one point here, ladies and gentlemen, that I want to make, okay? One point that I want to make. Notice how I'm including labels for everything. I'm just not putting 1 over 122.1232, as I saw some of you doing when I looked at this. I need to keep labels in there, because when we get to stoichiometry, we're going to be going from one substance to another one. So in this problem, we're all dealing with benzoic acid, okay? When we get to stoichiometry, it could be going from benzoic acid to a totally different substance. So you're going to need to have labels to keep everything straight. So just get used to doing that now. Now, I have converted this, because my grams cancel. I've now converted this to moles. My next step, my second step, was I need to go to from moles to molecules. So I know that 1 mole of benzoic acid has Avogadro's number of molecules of benzoic acid. I get my green out. I close my box here. I'm going to close that box here. I'm going to have enough room here. So I look and I say my moles here on top, moles here on bottom. Those cancel. I've now converted this into molecules of benzoic acid. Now my final step was to go to atoms of hydrogen. Atoms of hydrogen. So I know that if I have 1 molecule of benzoic how many atoms of hydrogen do I have? How many hydrogens do I have in that benzoic acid? 6, right? 5 here, 1 here. Don't forget that 1 there. So I have 6. I look at this, I should get a cancel. Molecules benzoic acid on top, molecules benzoic acid on bottom. So I get my cancel. I know that my label is going to be atoms of hydrogen. So when I do my math, multiply by top, divide by bottom, I'm going to take 5.49. I'm going to multiply that by Avogadro's number. I'm going to multiply that by 6. I get an answer. Then I'm going to divide that by 122.1232. And I get a value with 123 sig figs is 1.62 times 10 to the 23rd hydrogen atoms. 1.62 times 10 to the 23rd atoms of hydrogen. Final answer.